In part 2 of our pressure volume work series, we'll continue answering questions 2 and 3. Question 2 reads, a cylinder equipped with a piston expands against an external pressure of 1.58 atmosphere. If the initial volume is 0.485 liters and the final volume is 1.245 liters, how much work in joules is done? This question is very similar to question number 1, so if you're looking for a challenge, make sure you wait for question number 3, which will be done later on in this video. To do this problem, we first need to find delta V, and we can do that by taking the final volume and subtracting it from the initial. The final volume was 1.245, and subtracting it from 0.485, we end up with, using our calculator, 1.245 minus 0.485 gives us 0.76. 0.760. We just found out what delta V is equal to. All we have to do now is substitute the pressure, which is also given in atmosphere, and multiply it to the volume, which is given in liters. So we have work done is equal to negative P, which in our case is 1.58 times 0.760. Our final answer should have 3 significant figures. Taking the number on the screen times negative 1.58 gives us a number that's in liters atmosphere. That's negative 1.20. Negative 1.20 liters atmosphere. Just like we did in question number 1, we need to go from liter atmosphere to joules, and the conversion ratio is shown right here. So we take negative 1.20 and multiply that to, make sure you write the units down, times 101.3 joules over 1 liter times atmosphere. The reason why I oriented this conversion factor like this is so that these units will cancel out with these, leaving us only with joules. So taking the number on our screen times 101.3 gives us negative 121.6. We only want 3 significant figures, so we'll write down negative 122 joules. Notice that the sign here is negative, just like in question number 1. The reason for that is because there's an expansion. And whenever there's an expansion or work being done on the surrounding, then the work should be negative. In question number 3, we're asked, when fuel is burned in a cylinder equipped with a piston, the volume expands from 0.255 liters to 1.45 liters against an external pressure of 1.02 atmosphere. So here's our pressure. We need to find delta V. In addition, 875 joules is emitted, released. This means whatever your work is, we will subtract 875 from that. What is delta E for the burning of the fuel? Recall that delta E in one of our previous videos is equal to the amount of heat plus the amount of work. So the first thing that we will do is find out the amount of work, and then we will subtract 875 from that. Let's go ahead and do this. First, let's find out what delta V is equal to. 1.45 minus 0.255 is equal to 1.195. 1.195. Using the formula that we used in question number 2 and 1, we'll write down that work is equal to minus P times delta V. P is equal to 1.02, and I'll multiply that to 1.195. That gives me the amount of work in liters times atmosphere, which I'll need to convert like I did in question number 2. 1.02 times 1.195. Remember, this number should be negative. Negative 1.2189 liters times atmosphere. Now we'll take this number and multiply it to 101.3 to give us the number of joules. So multiplying this by 101.3 gives us 123.47. 123.47, and that number should be negative. So to find delta E, I'll take negative 123.47, and remember the question said emitted. Something was released, energy was released, so it should be minus 875. Using our calculator, negative 123.47 minus 875 gives us negative 998. And I'll stop after this 8 because this number doesn't have any numbers after its decimal. So negative 998 joules is the amount of energy for the burning of the fuel. And so there you have it. That is how to solve pressure, volume, work questions.